if we can fly right through this and then move on to 12.2. So we got a bunch of definitions. First definition I want you to write down is that of a polyhedron. And a polyhedron is a solid that is bounded by polygons called faces that enclose a single region of space. So, think about what a polygon is again. Polygons need to have all straight sides, right? So, would this box be a polyhedron?
Yeah.
Yes. What would be the shapes of all of its faces?
Squares, no, is this rectangle?
Yeah, I'd say they're all rectangles. I don't think that's a square. So rectangle, 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 they're all rectangles. So these would be faces of the polyhedron. All right. What part do you think would be the edge?
Corner.
Like this?
Yeah.
Yeah, so the edge, so our definition of an edge would be what?
Endpoints. Something.
Or two what meet?
Where two faces meet.
Yeah, where two faces meet, right? So if you got a face here and a face here, where they meet makes an edge. What type of geometric figure is an edge? Line segment, ray, line segment. Good. So for our definition of an edge, we're going to say it's a line segment formed by the intersection of two faces. So we've got faces, we've got edges. The third thing that we have is a vertex, where you think a vertex would be the points, right? And so a vertex would be where how many edges intersect or meet. Here, in this case, we have 3, right? So a minimum of 3 that intersect. So for a vertex, it's a point where 3 or more, you could have more than 3 edges in meeting. So a point where 3 or more edges meet. Okay, so there is a diagram here. So this front side just has a bunch of pictures on there. I figured I'd help you guys and not make you have to draw all of these. So right below it, we have a polyhedron. It's pointing to the face, it's showing the vertex, it's showing the edge. Okay, so your vertex is where your edges meet. Your edge is the long line segment where two faces meet, and then you got your faces. Okay? So can we determine the difference between what is a polyhedron or not a polyhedron? So on the bottom here are 2 examples of polyhedra, or polyhedron, however you want to say it. All the sides make polygons. Here all the sides are rectangles. Here your sides are what polygons? The bottom is a... Bottom is what shape? Parallelogram. The sides are what shapes? Triangles. Both of those are polygons. Over here, a cylinder is not a polyhedron. Why is a cylinder not a polyhedron? Nolan?
Because it is a circle.
Right, a circle is not a polygon. What needs to be true about a polygon? It needs to have all straight sides. A sphere is not a polyhedron. A cone is not a polyhedron. Okay? So we're looking for polygons for all the faces. If you don't have polygons for all the faces, then it's not going to be a polyhedron.
Wasn't this, well then what are things that aren't polygons?
It's not called a polyhedron, it's just a three-dimensional shape.
The parts of it that aren't a polygon.
The faces that are not,
Yeah, what are those called?
well, it's just a face that's a circle. So it's just a three-dimensional shape. It's just not a specific polyhedron. All right, so let's go through this first example on the back. Decide whether we have a polyhedron or not. If it is, name it. Is A a polyhedron?
Yes, it's a rectangle.
Yes. It is a polyhedron. Is it a prism or a pyramid? Those are going to be our two options we're going to go with.
Prism.
It is a prism. Okay. Now let's count the number of faces, vertices, and edges. Is everybody okay with me just using an F for face? Okay, so how many faces does that prism have? It has 6. Does everybody see where the 6 are?
Yeah.
Front and back, 4 around. So 6 faces. How many edges do we have? I've got 1, 2, 3, 4 in the front. 5, 6, 7, 8 in the back. 9, 10, 11, 12, getting around, so it'd be 12 edges. How many vertices would there be?
8.
Yeah. 4 in the front, 4 in the back, right? 1, 2, 3, 4, 5, 6, 7, 8. So vertices is equal to 8. B, is that a polyhedron?
Yeah.
Yes. Prism or pyramid? Bless you. It's pyramid, right? Does everybody see why it's pyramid? Meaning at a point. Okay, how many faces do we have?
7.
So the easiest way to do it is count how many sides your base has. 1, 2, 3, 4, 5, 6. So that
And
means
add
that means there's 6 all the way around.
And add 1.
And then the one on the bottom, so 7.
And the edges is usually the same as that, right?
Not necessarily, no.
Wait, no, not the edges, the vertices.
Nope. Here they weren't the same.
No. For a pyramid.
So let's count edges. 1, 2, 3, 4, 5, 6. And then there would be 6 all around.
And then 7.
7.
Like one by the tip and vertices in there.
Edge.
Oh, I think
Edge. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12 edges. How many vertices do we have? Yeah.
7.
There'd be
So
6
that thing.
and then 7. Good.
I was right, see?
Is C a polyhedron?
No.
No. Why is it not?
Because it has a shape that isn't a polygon.
Good. It has a face that is not a polygon.
Excuse me.
What?
It's possible to easy to have things that are both polygon and not polygon.
No. Because if you have a circle somewhere, then none of the other sides are going to be polygons.
It would only be like a cone or a cylinder.
Right. All right. In your Euler's theorem box, I would just write this following formula. If you need to label what each of those things means, label it. But there is a man named Mr. Euler. I don't know what his first name is. It's not pronounced Euler. It's actually pronounced Euler, like O-I-L-E-R. So Euler's theorem gives you a formula that can be used to look at the relationship between Bryce and Jamin, faces, vertices, and edges. And what this formula tells us is the following. You can take the sum of your faces and vertices. So if you do F plus V, it should get you to the same thing as your number of edges plus 2. And that works every single time. So F plus V is equal to E plus 2. It's your first formula you're going to need memorized for this test and quiz.
What are formulas are going to be like written for the final? Any of them?
You're going to put whatever you want on an index card.
Wait, is the final quarter or like everything?
Everything.
Oh.
So F plus V equals E plus 2. It's Euler's theorem. So using Euler's theorem to solve for an unknown amount of faces, vertices, or edges. So if you're not given a diagram of the three-dimensional shape, you can use Euler's theorem to actually find the unknown parts. You good? All right. So here we go. We're solving for the number of faces. So F plus V is equal to E plus 2. What's going to go in place of F? N. How many vertices do we have?
12.
How many edges? Plus 2. Combine your like terms on the right. 18 plus 2 makes 20. So if my three-dimensional shape has 12 vertices and 8 edges, how many faces does it need to have? 8. Right? Subtract 12 from both sides. So that means we have to have 8 faces. So I can create a polyhedron that has 8 faces, 12 vertices, 18 edges. Simple enough?
Excuse me.
All right, what?
If that's so, never mind. I thought I saw a contradiction, but I was wrong.
Okay. All right, last example.
This is diamond, right?
We want to identify the number of faces, vertices, and edges, and then check it using Euler's theorem. So,
Octahedron.
gentlemen, stop talking. How many faces do we have? Does everybody count 8?
Yeah.
How many vertices do we have?
6.
6. Everybody getting 6 vertices? How many edges do we have?
12.
Is everybody getting 12 edges?
Yeah, well,
Okay, so now let's check it using Euler's theorem to make sure we are correct. So F plus V, so 8 plus 6, is that equal to 12 plus 2? Yeah, 14 is equal to 14, right? So we know that we count it right when we look at the diagram.
it seems pretty simple.
Yeah. That's section 12.1. Questions with that? Yeah, it is easy. So let's see and make sure we've got this. I'm going to send you guys through. We don't even need practice spaces for this. So first thing, is that a polyhedron?
No.
Is that a polyhedron?
Yeah, what is that? What is that called?
I don't know what it's called.
Stop, David.
Been excited, yeah.
Polyhedron?
Oh gosh. It's a soccer ball.
Okay, Dominic.
Got a little more edges than a soccer ball.
Polyhedron? Polyhedron.
Yeah. Yeah, it's gonna meet right.
Yeah, it's... No. All right, now let's think back to concave and convex shapes. What's the difference between convex and concave?
What if the convex and out concave is in?
So is this convex or concave?
Convex.
Yeah,
Concave.
that would be concave. Good.
Concave.
Concave.
Convex.
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 All right, how many faces does that shape have?
2,
1, 2, 3, 4, 5, 6. How many vertices?
6.
6 vertices, right?
And 14.
1, 2, 3, 4, 5, 6. How many edges?
6.
How many edges?
6.
10.
Yeah, 6, right?
10, right? So is 6 plus 6 equal to 10 plus 2? Did we do our math right? Right? 12 is equal to 12? How many faces? That's the same one we did in our notes. 8. How many vertices? 6. 4 around. Well, don't count the inside part. So there's 4 around, top and bottom, so 6 vertices. How many edges?
1, 2, 8, 9, 10, 11,
12.
8.
How many faces?
4, 5, 6.
6?
7.
6. How many how many vertices?
8.
8. How many edges?
8.
Get all of them. It'd be 12, right? So you've got 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. Okay. That one's kind of hard to see the three-dimensional of it. How many faces? 1, 2, 3, 4, 5, 6, top and bottom, so 8. Good.
This one looks weird. It looks like it's
Because there's no dottedness to it. Vertices,
How many edges?
12, how many edges?
8 faces.
Yep. 18 edges? Good. How many
Oh.
faces here?
This.
5.
5? So everybody got the 5? Okay. How many vertices?
6.
6. How many edges?
13.
Not 13.
5 plus 6 is 11 plus 2 is 13.
You've got 1,
Oh,
2,
nine.
3, 4, 5, 6,
Oh,
7, 8,
9.
9. All right. Good.
Alright.
That is 12.1. Any questions?
No.
I think you got that. All right. So for 12.2, we're going to get into the surface area of prisms.
That we're gonna use like probably 5 times this summer.
We'll save cylinders for Monday.
More.
Yeah. That doesn't take us very long. 12.1. All right, so we're going to talk about surface area of specifically just prisms. Now, really quickly, let's talk prisms. What's the difference between a prism and a pyramid?
Prism is like it's
It's like
a 3D rectangle.
It doesn't necessarily need to be a rectangle. So if I have, now just watch this, don't put anything in your notes. I'm going to do my best here to make a three-dimensional shape. So if I make the base of a shape a parallelogram,
Oh,
if I were to make my sides go straight up,
no. Oh.
that was not very good. That should be done in the back. But anyways, prism or a pyramid? Prism, right?
It's a cube.
What would I do with these sides instead of going straight perpendicularly up? If I wanted to turn it into a pyramid, what would I do?
Into one point at the top.
I would put them on a diagonal and then connect them all together, right? And that would give me a pyramid, right? So in a prism, what needs to be true about the base shape and the shape that is parallel above it? They need to be the same, right? If it was a pyramid, would there be a shape parallel to the base?
There'd be a vertex on top.
Nope, there'd be a vertex on top, right? So, our definition of a prism, please write the following, is going to be a polyhedron with 2 congruent faces called bases.
Called bases.
Yeah,
Bases
called-
are loaded.
Called bases that lie in parallel planes. So if we look at this rectangular prism, the bases would be the bottom and the top, right? Okay. So if the bottom and the top are called bases, we need to have a name for the other sides, the other faces, which we call the lateral faces. So you got your 2 bases in any prism. The other sides that aren't the bases are going to be called your lateral faces. And the cool thing about prisms is your lateral faces will always, always, always be parallelograms. So lateral faces are parallelograms formed by connecting the corresponding vertices of the bases. So if you think about it, you got your 4 vertices of this base, right? You got the 4 vertices of this base. If I were to connect this vertex to this vertex to this vertex, I just made this lateral face, right? If I connected vertex, I just created that lateral face. That lateral face, that lateral face. Okay? Let's just skip lateral edges because that's not important.
Just cross it out.
Yeah, just cross it out. Now let's think about surface area. How do we find the area of a rectangle?
Base times height.
Base times height. Well, how many rectangles does this prism have?
6.
6 faces, right? Where all of them are rectangles. It happens to be that all these are rectangles in this shape. So if I wanted to find the total surface area of this prism, what could we do? What could we do to find the total surface area? Couldn't I find the area of this face, find the area of this face, find the area of this face, this face, this face, this face, and then add them all together?
Yeah, wouldn't you see base times height and then times height?
Well, they're not all the same. They're not all the same. If they were all the same as a cube, then yes, we could do that. They're not all the same.
It would be base times height of like the short one, which is times 2, and then
Sure.
base times height of the long one.
All right, so what is surface area?
You missed one.
I said cross off lateral edges. We don't have to worry about it. So your surface area. Your surface area is going to be the sum of the areas of a polyhedron's faces. So surface area would get you the total surface area. How do you think you would find lateral area?
Measuring it?
Nope. What faces would you take away if I was just looking for the lateral area of this shape?
The 2 small ones?
The 2 bases, right? The 2 bases. So the lateral area comes from the sum of the areas of the lateral faces.
What?
Okay? The lateral area is the sum of the areas of a polyhedron's lateral face. Last definition we need to cover is a net. How many of you guys have seen a cardboard box flattened completely? Have you seen flattened cardboard boxes in your life? Hopefully.
No, not really.
So if you think about if I were to take the tape off of this and flatten it completely down, I would have the net of this prism. And a net is a 2-dimensional representation of the faces of a polyhedron. All right, so the first thing you're going to have to do for your 12.2 homework is, given a net, can you find the total surface area?
Oh, wait. I put that wrong. Wait, don't put it down. I still have to write that. I missed the lateral area one.
Can you get it later?
Now, what are you doing now?
Well, I want to keep going here instead of waiting. Let's relax. Just get the lateral area, and then we'll go back for you to get the net, okay?
Okay.
All right, so for our first example, notice we have a prism here. It's a rectangular prism. Envision it getting flattened out. So now we found the net. So I want to find the total surface area. So what I can do is focus on each surface individually. What are the dimensions of that rectangle?
I don't know. We're only giving
5 by
6.
6. So the area would be what?
30.
30. What would be the area of that rectangle?
12.
It'd be 2 by 6, so it would be 12. What about that rectangle?
5 by
5 by 6 again, so that would be 30. And this rectangle would be 2 by 6, which is 12. What about that top rectangle?
10.
Be 10. The bottom one would be...
10.
So to find the total surface area, what are we going to do with those numbers? Add them all up. So 30 and 30 makes 60, 70, 80. 80 plus 24 is 104. centimeters. We're doing area, so what should we do with our units? Square it. Good. So surface area equals 104 centimeters squared. Okay? So find the area of each surface individually. I'm going to have you ignore the definitions for right and oblique prism because I feel like the diagrams there do it justice. Can you tell the difference between a right and oblique prism? Right. So I won't even write these. So right rectangular prism is one that is perpendicularly straight up.
Is there any difference in how we got to get the answer?
Yes, because the formula that we're going to go to next only works for right rectangular prisms. Does not work on obliques. So you got to make sure it's always going to be right. So please write this down in the surface area, a right prism. So S is equal to 2. Make sure that B is a capital B. It's important. Make sure that P is a capital P.
I don't think it's really important.
Do not make that H a capital H. Make sure it's a lowercase h.
I don't think it's really important, is it?
Yes, it is. So there's a difference between capital B and lowercase b. Whenever you see a capital letter B, you should be thinking that is specific to the base. So now, big B is representative of the area of the base. Why do you think to find surface area, I can find the area of one of my bases and then double it?
Because they're the same.
Because there's two bases in a prism, right? There's the top, the bottom. The capital P stands for the perimeter of the base. So whenever you see a capital letter, you're thinking of the base. Lowercase letters are representative of the prism. So lowercase h stands for the height of the prism. So how high up does it stand? So now let's think about this formula. We're all good with finding the area of this base and this base, right? It's a rectangle, it's just length times width. Double it, that gets you your two bases. Now think about your lateral area. Perimeter of this base is all around, right? That's how we find perimeter, add up all the sides. Well, this length of the perimeter times the height of the prism, wouldn't that get you the dimensions of this base? Yeah? Wouldn't the perimeter section of the base times the height of the prism get you the dimensions of that base? Yeah, and the same with the other two sides because they're the same. So that's where this formula comes from. So let's do these last two examples. Let's find the surface area. So what I like to do is organize my thought process by finding capital B, finding capital P, finding lowercase h. Let's do lowercase h first, because that's the easiest. How high up is that prism standing? 2 feet. So that's going to be 2. So if it's standing up 2 feet, then this bottom parallelogram is going to be the base. How do you find the area of that?
8 times 3.
Good. So that's going to be 24. How am I going to find the perimeter of that same base?
8 times 2 plus 3 times 2?
Sure. Or I'm just going to write it out like this. But that would be exactly right, Dominic. So 16 plus 9 is what? 16 plus 3 is 19. 19 plus 1 is 22.
Really close to
So now can we plug those into the surface area formula? Sure. 2 times B plus PH. So 2 times 24 plus 22 times 2 gets us 48 plus 44. So what does that get us? 92? So 92 feet squared would be our surface area. Okay? So rectangular prisms are going to be your easiest ones because it's easy to come up with the area of a rectangle. It's easy to do the perimeter of a rectangle. Where it gets more difficult is when you have a triangular prism. So your base shape is now a triangle instead of a rectangle. Would it be incorrect if I would have made my base be the front and the back instead of the top and the bottom? Would I still get the same answer?
Sometimes you would.
No, you always would. Because what would be the area of this front base?
What is the 2?
Yeah, so what would be my big B? It would be 8 times 2, which would be 16. My perimeter would be 8 plus 8 plus 2 plus 2, so 16 plus 4 is 20. How high up would it be standing if the front was its base? If I flapped it forward so that it was sitting on its front, it would be 3, right? So 2 times 16 is what? 32. 20 times 3 is what? Is 60 plus 32, 92? Sure. Okay, so it would get me the same surface area. All right, so let's do the triangular prism one. Now, notice it would be easy to say, oh, the base is what it's sitting on. Go parallel up. Do you have a congruent rectangle right directly above it? No. So that is not the base. So what's tricky about triangular prisms is they always have the base in the front and the back. So you have to think about that as being your base. So we need to solve for our B. We need to solve for our P. We need to solve for our H. Let's do our H first. If I were to flip this forward and have it sitting on that triangle, how high up would the prism be standing? 9.1. So that's going to be your height of the prism. Let's do the perimeter next. That one's going to be easy. What will be the perimeter of that triangle? Perimeter. Add up all the sides. This side's 8, this side's 3. What's this side? 8, because it has the little congruent there. So 8 plus 8 plus 3 is what? 19. Good.
Where'd you get the second 8?
Because it's giving me the congruent marks. It's isosceles.
Oh, I didn't see that.
All right, now we need to find the area of this triangle. So I'm going to rewrite this triangle over here off to the side so I can think a little bit. So here are the dimensions of this triangle. How do we find the area of a triangle?
1/2 base times height.
1/2 base times height. Do I know the base of this triangle?
3.
It's 3. Notice this is a lowercase b. It's not the same thing as my big B. Do I know the height of this triangle?
8.
It's not going to be 8. What type of triangle does it create? Oops, took away too much. When I just look at half of it.
Right?
Right triangle. What's the dimensions now of this leg of the right triangle?
1.5?
1.5. Good. So that's 1.5. The hypotenuse is 8. My other leg is x. Someone give me a Pythagorean theorem equation to solve for the height of that triangle. So 8 squared equals 1.5 squared plus x squared. Okay, let's do some math. 1.5 squared is, 2.25 plus x squared equals 64. What are we going to do? 64 minus 2.25 gets us 61.75 equals x squared, and then what? Square root that. And we get about 7.9. So that 7.9 is going to go into which variable in our area formula? Height.
After the 3.
Yep. All right, so now all of that work to find our capital B. Yeah, it's a lot of work, but that's okay. We can handle it.
Is there a simpler way?
Nope. 0.5 times 3 times 7.9 gets us 11.85. So there's your capital B. So that's why I said triangular prisms are more work. Okay, now can we find the total surface area? Yeah. Plug those in. So S is equal to 2 times our B, which is 11.85, plus our perimeter times the height of the prism. So now it's just some fancy calculator work. 2 times 11.85 plus 19 times 9.1 gets us 196.6. What are my units? Meters squared. Okay. So surface area.
We're running out of time.
It's okay. We're done.
Really? But there's a whole.
We're going to save cylinders for Monday. Okay? So those triangles are going to be the one.